Hey guys, welcome back to another Swift programming logic tutorial. And in this tutorial, I'm going to be talking about big O notation and what it is and how to use it. So I'm not going to be talking about Swift specific things here, but it's still programming concepts in general, so that's why I'm putting it in this series. So basically, big O notation allows you to measure time complexity and space complexity. In this I'm just going to be talking about time complexity since it's a bit more easy to explain, but basically it's how efficient your program is. So one thing you need to understand about big O notation is that it's not actually exactly how accurate it is, it's more just an estimation. So something which has a list of I don't know, let's just say something which has to find an item in a list using linear sort of any item. So if one time you're going to use it with let's say 10 elements, and that will be O of n because you have to loop through the entire list once, which is why it's O of n, which basically means it's going to take O times for the n, which is the space of a list, and let's say the list was also 100 items big. Both of those would be O of n, even though the one with 100 items would obviously take longer because it's bigger data list. But yeah, so basically you need to understand it's an approximation and not the exact thing. So I'm just going to explain what most of these are. But one thing you need to another thing is that O of n cubed is basically like you don't really need it because most of the time if you're gonna have something like that you might as well just drop it into O of n squared. The only reason you ever use O of n cubed is if you were looping through a list, then you had to loop through the list 2 times for every time you loop through it. But that would actually be O of n squared, which is actually O of n 4, so it wouldn't really make sense. But yeah, so basically O of n is basically constant, which means it's never going to change. So I just go here and add a text tool. Where is it? Here. So if we just add here, an example of this would be if you're trying to print anything or just do something which is always going to stay the same no matter what you have. So let's say you have a function which function that prints the first item of a list, and then you just do print list 0. So no matter how big this list is, even if this lists 1,000 items, it's always going to only take one time because it only needs to print the first one, which is here. So now O of log n is basically kind of like this, but not really. So O of log n basically means it's going to be a bit slow at the start, but then it's going to speed up towards the end. So an example of this would be something like binary search. So basically when you split everything in half, so binary search an array, split the list in half, split list in half every time. And one thing you should know is that I know I've said that a lot, but basically whenever you're splitting something in half or doubling something or tripling something, it usually results in it having a curve which is either exponential like these, or I don't know what the opposite of exponential is, but just like this, so it's like, and then flattens out. But yeah, binary search is O of log n because it becomes exponentially faster. For example, if you had a list of 1,000, then you'd binary search and it takes some time. But then if you do a list of 2,000, even though it's double as big, it's only going to take one iteration for it to split it in half, and now it's only a list of 1,000 again. So that's why this is a lot really fast. So yeah, and then O of n is probably the simplest one on here. It just means it's going to take as long as it takes. So the number of operations required is directly the same as the number of inputs. So for example, if you have a function that prints every item in a list, then it's going to have to loop through the entire list and print every item. So that's why it's O of n. When you increase the list size, it's going to also increase the time it takes to print every item. So basically O means the number of operations and n is pretty much any variable, but it's usually referring to the number of inputs. So if it's in a list, it's the number of items in a list, or that kind of thing. So then we can move on to the exponentials. So I'm actually going to be ignoring O of n cubed because it kind of groups into O of n squared. But yeah, so basically O of n squared would be something like, let's just say we're trying to make a sorting algorithm. So for example, you know how sorting algorithm works. It loops through the entire list and then it actually finds the lowest one, then keeps repeating. So I know that's not a very efficient one, there's more efficient ones, but that's just the most basic one. So a sorting algorithm that loops through the list for every item to find the lowest one. And basically it's because, let me just make an array here, and let me just do something like 1, 3, 4, 2, 6, 5. So if you wanted to sort this, all you would have to do is first you'd loop through and you'd get 1, 2, 3, 4. So you'd get 1 as the lowest, and go here, and I'm just going to create a new one. So that's what you do first. Then what you do is you'd actually remove 1, so ignore 1, and then you look for the other ones. So then you go find 2, then you loop through again, find 3, loop through again, find 4, and 5 and 6, just like that, and that's how you get it sorted. So you can see for each item in the list, it actually needs to loop through the entire list. Well, not the entire list, but you know, you still have to loop through the list, which is why it's O of n squared. Then O of n cubed is kind of a similar thing, but you just have to kind of loop through another list as well. So I'm just going to ignore that. And then finally we have the exponential. So this one's called a quadratic time complexity. This one is called a cubic time complexity. O of n is called linear. O log n is I'm not sure what it's called, but I think you can just say O of log n. Then O of 1 is just constant. And then O of n to the n is basically just exponential. So this would mean that for every item in this list, you'd also have to repeat every other item in this list. So if you're looking for 1, then you go to 3 and then check every other item, like that. And that's how the time can really increase for exponentials. So I'm just going to write exponential here. It's a bit hard to think of an actual problem for this since they're quite rare. Usually they're just O of n squared. But yeah, exponential just is really bad, and usually you never want to do this because usually with most of these, especially these 3 here, you can't really ever notice it unless you're working with huge data sets. But especially when you go to these exponential ones, you start to encounter a bit of loading time, things like that. So yeah, you just really want to never make sure you have this. And then there is actually another option. If I just go over graph here, there's another option which is something like this, I believe. Well, not really that, it always have a curve, but it's like this, and it's actually called O of n factorial, O of n factorial, and that is even slower than exponential. So yeah, these two, and especially all of these up here, you want to try and avoid it if you can. I mean, O of n squared is quite hard to avoid, you see that a lot, but these 3, you really don't want to be having these, since they're just going to cause trouble. And yeah, thanks for watching, and that was kind of big O notation. I know it's a bit hard to understand, but hopefully I explained it, each one, well. But yeah, thanks for watching, and I'll see you guys in the future tutorial. Bye!